Greetings everyone. So in this video we are going to discuss in detail about our topic, which is alcohols. So if you just take a basic understanding of alcohols are those organic compounds. Alcohols are those series of organic compounds which have hydrogen bonding in them. Those organic compounds which have hydrogen bonding. What does this mean? We have heard that hydrogen bonding occurs in elements in compounds which have atoms like nitrogen, oxygen, and fluorine. But what is the case with alcohol? If you just see the structure of water, this is oxygen, and here we have the hydrogen bond. This is another it's the hydrogen attached with a chemical bond, covalent bond. This is a covalent bond, and this is the structure of H2O. Now, what is an alcohol? Alcohol basically, there are three major classes: alcohols, phenols, and ethers, which have a structural resemblance with water. How? Let's see. This is the molecule of water, right? If I were to take this entire molecule, if I were to if I were to place another water molecule, if I were to remove the H from this water molecule, and instead of H I apply one R, alkyl group, then this is an alcohol. And what if I remove what if I, instead of applying an R chain, I apply a benzene ring over here, benzene ring, so it will become a phenol. And I take oops, what if I take water and remove the hydrogens, both of the hydrogens, and add alkyl group here and alkyl group here? It will become an ether. So these are the three things that we need to understand. So if you were to suppose we are supposed to be given to give the angles of bond angles of alcohol, phenol, and ether, as well as the geometry, that would be pretty similar. All of them are having a very similar geometry, which we're going to discuss as well. So if you just talk about the discovery of alcohols were discovered in the early 18th century during the destructive distillation um, by Michael Faraday. That was the first alcohol to be discovered, was by Michael Faraday. It was ethanol, and by then we have used alcohols for many different purposes. We have sanitizers, which include alcohols. In sanitizers we have rubbing alcohol. That rubbing alcohol is isopropyl alcohol mixed with water, which basically works as a sanitizer, as an antiseptic. And alongside that, we have alcohols used for drinks. Ethanol is used for drinks. Solvents, alcohols which are used for solvents as well, as solvents. For example, some alcohols are used for dissolving fats, oils, varnishes. And alcohols are also used for antifreeze agents. As antifreeze agents in automobiles, such as methanol and ethanol are excellent antifreeze agents, alongside which they are also used in pharmaceutical production. For production of various pharmaceutical products, alcohols are used. Pharmaceutical. products, alongside which they are also used for the sake of producing, let's say, this production of pharmaceutical products, for the preservation of biological specimens. Ethanol is used for the preservation of biological specimens. So that is again an important thing. Preservation of biological specimens. We preserve biological specimens in alcohols, right? So these are some of the uses of alcohols. Alongside which, if we talk about phenols, on the other hand, phenols are were discovered by Runge scientists during the destructive distillation of coal tar. Coal tar. And if we just talk about the structure of phenol, we are going to have a separate video in which we are going to discuss the exact structure of phenol and entire details of chemical reactions. But for now, we need to understand that it is also known as carbolic acid. Why do we call it carbolic acid? Because over here, this ic sign represents the OH group or the alcohol group, and carbolic acid, carb represents the benzene. We are going to discuss it in further classes. And then we have ether. Ether was discovered uh, during the distillation of H2SO4 sulfuric acid with ethanol. So we are going to discuss it in detail as well. For now, we need to understand the alcohol. So starting with the very basic, the structure of alcohol, it is having this as the basic formula, ROH, alkyl group attached to an OH chain. Now, if you just see the structure of alcohol, um, alcohol basically is having the carbon in alcohol is having sp3 hybridized orbital. Carbon in alcohol is having sp3 hybridized orbital. For example, let's draw the structure as well so that it becomes easier to understand. This is one sp3 hybridized orbital. This is another sp3 hybridized orbital. Sorry. This is another sp3 hybridized orbital. Here another sp3 hybridized orbital. Another sp3 hybridized orbital. Right? These all of them are sp3 hybridized orbitals. sp3, 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 and sp3. These are sp3 hybridized orbital of carbon. We are drawing the structure of methanol for now for the ease of understanding methanol. And we take on the other hand side, we are going to take the oxygen. Now, oxygen is having sp3 hybridized orbitals as well. It is having 4 sp3 hybridized orbitals. 4 sp3 hybridized orbitals are there. Let's draw those as well. So, over here, this is one sp3 hybridized orbital, sp3, sp3, and these two things which are present in these sp3 orbitals. These are also sp3 hybridized orbitals. sp3, sp3. Now we might see that over here there are 4 sp3 hybridized orbitals, and one sp3 hybridized orbital forms a bond with carbon, which is sp3 hybridized bond, while two of the sp3 hybridized orbitals are having two pairs of electrons in them, which is these pairs are known as lone pairs. These are lone pairs which are present in two sp3 hybridized orbitals, which means two lone pairs of oxygen are present in two sp3 hybridized orbitals. Alright, now let's just move on here we have hydrogen, and here we have the s orbital of hydrogen. S orbital of hydrogen, right? So this is the very basic structure of methanol. This is a very basic structure of methanol. Now in this structure we might see that there are two major types of bonds. Oxygen in the structure of ethanol is forming sigma bond, is forming two types of sigma bonds. One is the bond with carbon to oxygen bond, which is sp3 hybridized bond, and second type of bond is oxygen to hydrogen bond, which is sp3s bond. Now the question arises that which bond is more stable, which bond is more reactive. So the bond which is more stable, if you were to write the stability of the bond, stability of the bond, so the bond which is more stable, the bond which is more stable is this. This bond is more stable. The oxygen to hydrogen bond is more stable than carbon to oxygen bond. Reason behind it is that the oxygen to hydrogen bond is having an s orbital with complete 100% s characters, due to which the nuclear attraction is higher, due to which the electron pairs is more driven towards the hydrogen. Due to this reason, it forms a bond which is more stable as compared to the carbon, as compared to the carbon to oxygen bond. And if we just look into, if we just look into both of these bonds, both bonds are reactive because of the presence of more electronegative oxygen atom. So it is important, it is worth considering that the structure of alcohol, due to the presence of 4 sp3 hybridized orbital, is a tetrahedral structure. But that tetrahedral structure has a bond angle of 108.9 degree instead of 104.5. It should be 104.5 because it is nearly similar to water, but because of the presence of methyl group, which is dissimilar group with hydrogen, such that in water we are having two similar groups, hydrogen and hydrogen, due to which the repulsion is less. But in methanol we have an alkyl group and a hydrogen group, which are two dissimilar groups. When they are repelled, the repulsion is higher, due to which the bond angle becomes greater. Now, this is a point over here. And when it comes to its physical properties, it has, first and foremost, because I mentioned previously that they are having OH group with them. That OH group makes them highly makes the carbon highly electropositive, and itself the oxygen is highly electronegative, due to which it becomes the cause for the formation of hydrogen bonding. And because of this reason, it has, comparatively, if we just talk about its melting and boiling point, comparatively it has a higher melting and boiling point than it is a higher melting and boiling point than alkanes. And if we just look into their solubility is also higher than in because higher in water, because they are having hydrogen bonding in them. And another important factor over here is that its physical state. In physically, these are toxic, colorless liquids. These are toxic, colorless liquids with a sweet smell, with a sweet smell and burning taste. So, up to butanol, up to butanol, 4 carbon butanol, they are toxic colorless liquid with a sweet smell and burning taste. But greater than butanol, from 5th carbon onwards, they are waxy solids. And when it comes to its solubility, solubility is such that they are dissolved and they are dissolvable in water. But with the increase in the number of carbon atoms, there is a decrease in the solubility because of the increase in the polar in the non-polar segment. And when it comes to the trend of melting boiling point, the melting and boiling point is in such a manner that when there is an increase in the number of carbon atoms, generally they have a higher melting and boiling point. But when they have increase in the number of carbon atoms in the alkyl group, then they have an ultimate increase in the boiling point. Increase in boiling point due to increase in carbon atom. So this is an important point to consider. Alongside which, the thing which is worth considering is that straight chain alcohols are having a higher melting and boiling point than branch chain alcohols, because branch chain alcohols are more reactive and are more likely to bring a nucleophile towards themselves, due to which they can be more because due to which they can be less stable. So they are having higher melting and boiling point. Now let's just move on to another fact which is worth considering about alcohols. Alcohols are slightly acidic. They are slightly acidic. Their pKa value is 16 to 19. pKa is 16 to 19, which means they are slightly acidic. And if you just take it and take it in a pretty easy way, they are slightly acidic. And if you were to check its acidity, it can be defined in terms of its acidity can be defined in terms of the structure it has. We just see the structure over here. Oxygen is an electronegative atom, and because of its electronegativity, it makes it gains a partial negative charge because of the accumulation of the electron density towards itself, and this part, which is the hydrogen, becomes partially positive. And due to this reason, the hydrogen becoming partially positive, it acts as an acid. But it depends on the type of alkyl group which is attached to the alcohol or hydroxyl group, which determines that whether the acidity of alkyl alcohol or alcohols would be higher or not. So for that, we can draw a reactivity series. We can draw an acidity series. We can draw an acidity series in which the acidity can be given as primary alcohol greater than secondary alcohol greater than tertiary alcohol. So why is the trend so trend is like this? The reason behind it is that primary alcohol has no steric hindrance. There is no steric hindrance in primary alcohol, due to which the primary alcohol does not has primary alcohol gives an extended amount of area for the nucleophile to come and attack over the proton and thus cause a reaction, due to which it has, because of no steric hindrance, primary alcohol is a good acid, while tertiary alcohol is having a large steric hindrance, due to which it gives a limited area for the base to come and attack the proton, due to which tertiary alcohol is least acidic and primary alcohol is most acidic. Second reason is hydrogen bonding, such that when we if we just dissolve primary alcohol in water, if we dissolve primary alcohol in water, then the primary alcohol will have its oxygen to hydrogen bond weakened. The oxygen to hydrogen bond will start to weaken. Reason behind it is that the hydrogen bonding which would be formed in water would start to weak this oxygen to hydrogen bond, and due to this reason the reactivity of proton would be increased, such that proton can be easily attacked by any nucleophile, any base, and form a salt. And in that way, that increases its reactivity and acidity, due to which primary alcohol is greater than secondary alcohol than tertiary alcohol. And there's a famous reaction. This is a reaction which can be used for testing the acidity as well. When we are going to react sodium with ethyl alcohol, just like sodium reacts with water to produce hydrogen gas, in the same way ethyl alcohol reacts with sodium to produce hydrogen gas. And apart from the hydrogen gas, we have got a compound known as an alkoxide ion. It produces an ion, alkoxide ion, which is sodium ethoxide. Right. Now let's just move on to its preparations. If you were to prepare alcohol industrially, methanol can be prepared. Methanol can be prepared industrially. Basically, methanol is also known as wood spirit. Why do we call it as wood spirit? Because in earlier times it was prepared by the destructive distillation of wood. We used to burn wood at a very high temperature and pressure, which produced methanol, which is known as, due to this reason, it is known as wood spirit. And nowadays it is prepared by reacting water gas. I take water gas. What is water gas? Water gas is this: carbon monoxide plus H2O. Water gas, and I react it in the presence of a very high temperature, 450 centigrade and 200 atm. Zinc chloride is a catalyst. It's not a zinc chloride, but it's the it's chromium oxide and zinc chloride. Yes, these are the catalysts. Yes. So these are the catalysts, and I react it to form methanol. So this reaction happens in such a manner. Number one, water gas is passed through a purifier. It is sent to a purifier where the impurities are removed. Then it is sent to a compressor. Within the compressor, the gases are compressed at a very high pressure of around 200 atm, after which it is sent to a reaction chamber where the reaction happens at a very high temperature of around 450 centigrade, um, in the presence of catalyst zinc chloride and chromium oxide, uh, during which the methanol vapors are formed. Those methanol vapors are then sent towards the condenser for the gas to cool down, and from the condenser there is a pipeline, which is known as a recirculation pump, which basically pumps pipeline, which is a recirculation pump, which pumps the unreacted carbon monoxide and hydrogen back into the compressor, back into the compressor, which are then again used in the reaction mechanism. While the final collector from the condenser is sent to the final collector where the methanol is collected. So this is all about the formation of methanol at industrial level. But if we were to talk about its formation at indust the formation of ethanol at industrial level. Industrially, ethanol is produced by with the help of biological organisms known as yeast. Microscopic organism yeast Saccharomyces cerevisiae, and that is done with the help of a process known as fermentation, which is also known as anaerobic respiration. This process requires a temperature of around 25 to 35 centigrade, and that is carried out in the conditions. It is basically a process that occurs in the cells of microorganisms, and it happens in such a manner that we provide the microorganism with a proper aeration and provide microorganism with proper air. We provide them with proper with a dilute uh, with proper aeration, a dilute solution, and we provide them proper aeration, a dilute solution, and proper aeration, dilute solution, and preservative. And without any preservative, no preservative, it we can utilize starch, we can utilize molasses, we can utilize fruit juices to produce ethanol from fermentation. So when we use molasses is basically these are crystallized structure. These are crystallized structure which are used, which are prepared as these are crystallized structure which are obtained as a byproduct as remnants during the formation of sugar in factories. So molasses, it's having the formula as this C12H22O11. It's a dimer actually, and that basically when it is achieved, it is ethanol is achieved from molasses in two steps. What are those two steps? Number one step is that molasses is converted into glucose and fructose using the enzyme invertase enzyme C6H12O6 C6H12O6. This is glucose, this is fructose, and then this glucose which is produced this glucose which is produced this glucose which is produced is then used for is then react is then converted into ethanol is converted into ethanol using the enzyme zymase. So this is the entire reaction. Now if we just talk about the formation through starch what we actually do is we take starch C6H5O11. This is basically a polymer, so I'm going to write N over here. Alright, first starch is converted into maltase using the enzyme diastase, and then maltase is converted into maltase is converted into maltose sugar, which is converted into glucose with the help of maltase enzyme, and then the glucose is converted into zymase is converted with the help of zymase enzyme into ethanol, carbon dioxide. So this is a three-step process. Three-step process. So that's all about the industrial preparation of ethanol and methanol. Ethanol basically it is also known as 100% ethanol is known as absolute alcohol. During fermentation, the maximum yield which we can get is 14%, and the normal yield is something around 12 to 14%, and maximum yield is 14%. Now, in order to make the alcohol concentrated, we repetitively distill the alcohol. Repetitive distillation, which produces 95% ethanol, which is known as rectified spirit. This is known as rectified spirit. I name this rectified spirit. And what I actually do is I take the rectified spirit and I redistill it again and again. Redistillation, I distill it again and again. I perform its distillation in the presence of calcium oxide. At that point, I will get absolute alcohol, 100% ethanol, also known as absolute alcohol. Now, sometimes what actually happens is people, because absolute alcohol is extremely toxic, that people can use it for um, irrelevant causes. So what we actually do is sometimes we denature ethanol by adding 10% methanol with a little bit of pyridine or acetone in it, due to which the ethanol is denatured, and that is known as a denatured ethanol or methylated spirit. Methylated spirit. So this is all about the preparations. Now let's just look into some chemical preparations as well. First preparation is named as the hydration of alkene. When we That's the reaction we have already covered. Hydration of alkene, when we use cold concentrated sulfuric acid, then ethyl hydrogen sulfate is formed first, and then it is boiled in water at 100 centigrade to form ethyl alcohol. That's something already done. This is another reaction. It is known as hydrolysis of alkyl halides, such that we use we use caustic soda or potassium hydroxide in the presence of water, and and then we actually get ethyl alcohol in this reaction. Second reaction is Grignard's reagent. When we use Grignard's reagent with a carbonyl compound, we basically get an alcohol. If it is formaldehyde, then we get primary alcohol. If it is acetaldehyde, it is secondary alcohol. If it is propanone, it is tertiary alcohol. All right, and these are all the reactions which I mentioned right now over here. We discussed even the entire mechanism. Okay, so this is basically a reaction when we can also obtain alcohol by catalyte by hydrogenation. We can also obtain alcohol by reduction of carbonyl compounds. By reduction of carbonyl compounds. So there are two methods of reduction of carbonyl compounds. Number one is the catalytic reduction or the catalytic hydrogenation, which we have previously studied. We take hydrogen at a temperature of around 300 centigrade, 200 centigrade, 250 centigrade with nickel, platinum, palladium, and we actually get alcohol. And second method is chemical reduction. This is chemical reduction. And chemical reduction is in such a manner that over here we take a carbonyl compound and a strong reducing agent, lithium aluminum hydride or sodium boron hydride. At that point we will get alcohol. When we're going to react Grignard's reagent with either an ester, when we're going to react Grignard's reagent with an ester, then at that point we are going to get ketone, and that ketone will further convert itself in tertiary alcohol. Tertiary alcohol. This is an important thing. Now, Grignard's reagent reacting with acetone would convert it into tertiary alcohol. Alright, and whenever we are going to perform the reduction, chemical reduction of acetic acid, chemical reduction of any ester, chemical reduction of ester or a carboxylic acid, at that point we will get at that point we will get alcohol. If acetic acid is reduced with the help of lithium aluminum hydride, it's going to produce a primary alcohol, and if methyl acetate is reduced, it's going to produce primary alcohol. Now, these are the mechanism. Now let's just move on to the sum of the reactions. First reaction which we are going to have, now if you just take the reactions in account, we have two major reactions which happen in alcohols. First reaction is in which carbon to oxygen bond is broken. Carbon to oxygen bond is broken. Now that is a reaction in which a nucleophilic attack happens. Nucleophilic attack happens. And second thing which is important to be understood is attack on electrophilic carbon. There is attack on electrophilic carbon by the nucleophile. Second thing which is important to understood is oxygen to hydrogen bond, such that the oxygen to hydrogen bond, when this bond is broken, this leads to an electrophilic attack. Electrophilic attack. And that electrophilic attack is because the oxygen is in because of nucleophilic oxygen. Nucleophilic oxygen attacky. So now which one is more frequent? Which one is more likely to happen? The reaction which is more likely to happen is carbon to oxygen bond, because carbon to oxygen bond is a weaker bond as compared to oxygen to hydrogen bond. Oxygen to hydrogen bond is much stronger, due to which carbon to oxygen bond reaction is much likely to happen, more likely to happen. And when it comes to the reactivity reactivity of carbon to oxygen bond reaction or the nucleophilic reaction, the reactivity is in such a manner that reactivity is in such a manner that tertiary alcohol are the most reactive as compared to secondary alcohol as compared to primary alcohol. While if you talk about reactivity of oxygen to hydrogen bond breakage, then that is the inverse. Primary alcohol greater than secondary alcohol greater than tertiary alcohol. Right. So this is all about it. Carbon to oxygen bond is tertiary alcohol greater than secondary greater than primary. Reactivity of oxygen to hydrogen bond is primary alcohol greater than secondary greater than tertiary. Right. So Um, the reason behind it is simple. Again, it's the steering hindrance that happens. Because of the steering hindrance, the positive um, bulky groups around the tertiary alcohol makes it more difficult for the electrophilic carbon to react. For It makes it more difficult for the electronegative oxygen to be approached by any electrophilic agent, due to which primary alcohol has the most reactivity when oxygen to hydrogen bond is broken, and tertiary alcohol has a released reactivity when the oxygen to hydrogen bond is broken. While it becomes easier for the nucleophile to come and attack over the tertiary alcohol when because of the bulky positive clouds which can easily approach the nucleophile, which can easily approach uh, the the electrophilic carbon. The nucleophile can easily approach the electrophilic carbon because, of course, the nucleophile is negatively charged, and that comes towards the electrophilic carbon through by passing through a positively charged bulky group. That positively charged bulky group attracts the nucleophile towards itself, and that's the reason that which makes tertiary alcohol more uh, reactive when it comes to carbon to oxygen bond cleavage, while makes them most unreactive when they have oxygen to hydrogen bond cleavage. And second reason is hydrogen bonding, which is, of course, when we are going to put alcohols in water, the oxygen hydrogen bond is going to become much weaker, due to which it would become much reactive. It is the most in primary alcohols and the least in tertiary alcohol because, again, of the steric hindrance. Now let us just focus on few reactions involving this understanding. So this is a carbon to oxygen bond breakage reaction. This In this reaction, what we actually do is, whenever an hydrogen halide is reacted with alcohol in the presence of zinc chloride, in the presence of anhydrous zinc chloride, and this is concentrated HCl, then we get the alkyl halide. So this base test is the basis for identification, distinguish between between primary, secondary, and tertiary alcohol. This is this forms a oily, waxy layer of ethyl halide over the container. So this test is known as Lucas test. And if in the Lucas test, if there is a tertiary alcohol reacted, then tertiary alcohol will react immediately to form an oily, waxy layer of ethyl chloride. If there is, let's say, a secondary alcohol involved, then oily, waxy layer would be formed 5 to 10 minutes later the test. And if there's a primary alcohol involved, then will have the primary alcohol primary alcohol will have the reaction done in reaction primary alcohol will have the reaction done immediately. Tertiary alcohol will have the reaction done upon heating. Primary alcohol will have the reaction done upon heating, and tertiary alcohol will the reaction done immediately. That's all about it. And these are sort of the reactions. These are also carbon to oxygen bond cleavage reactions, in which phosphorus trihalide or pentahalide react with alcohol to produce alkyl halide, and when they react with thionyl chloride in the presence of pyridine, it is ethyl chloride that is obtained. And when alcohol reacts with concentrated H2SO4, it basically, in the presence at 170 centigrade, produces ethene. And when there is a use of when there is oxidation of alcohols, such that when we are going to oxidize primary alcohol in the presence of potassium dichromate and the concentrated H2SO4, we will actually get acetaldehyde, which would further convert itself into acetic acid. And there's another important thing, that when we instead of this, let's say I am using secondary alcohol, then what I will actually get is, if I use secondary alcohol, I will get ketone, and I will get ketone. This reaction can be done by potassium permanganate as well, but secondary alcohol cannot be oxidized by potassium permanganate, nor can the tertiary alcohol be oxidized by potassium permanganate. Over here, secondary alcohol is converted into ketone, and ketone cannot be further reacted. And tertiary alcohol does not undergo a chemical reaction. Tertiary alcohol does not undergo a chemical reaction, an oxidation reaction with potassium dichromate and in the presence of acidic H2SO4. Instead, it undergoes an elimination reaction. The same mechanism of alkyl halide beta elimination reaction happens, which produces alkene. So that's about it. Another important thing over here is that whenever we are going to react alcohol in the presence of concentrated H2SO4 at 140 centigrade, and the let's say if there is an excess of alcohol is reacted in the present in the concentrated H2SO4 at 140 centigrade, then at that point we will get an ether instead of an alkene. Now that has a different mechanism that how ether is formed. First, there is formation of an oxoniamine in ether, and in the second step, the oxoniamine forms an other intermediate oxoniamine, and that intermediate oxoniamine is further hydrolyzed. There's further hydrolysis of oxoniamine, which forms the final product, which is diethyl ether. Anyways, we are going to discuss it in ethers as well, so that's another important thing. Now, cleavage of glycol. Glycol, also known as vicinal diol, also known as 1,2-diol, is basically a compound which can which whenever we are having two hydroxyl group on two carbon atoms, it is known as a glycol. When there are three OH group on three successive carbons, then it is a glycerol. And when we are going to react glycol with a periodic acid, then at that point it's going to give us methanals, two methanol or two formaldehyde, and byproduct is iodic acid. So in this reaction, periodic acid is a strong oxidizing agent, and because of its strong oxidizing property, it is also used as a biological stain. It is also used as a biological stain. It is also used as a staining in biological processes like PCR. So this is an important thing, and this test serves as an identification test. This serves as an identification test for this serves as an identification test for glycol, and it is selective for glycol. It is selective for glycol, and it serves for identification. And another important thing that needs to be considered is that another important thing that needs to be considered is that another important thing that needs to be considered is that we have a test which we use to distinguish between methanol and ethanol. That test is known as the iodoform test. That test is known as iodoform test. That iodoform test is in such a manner that when we react iodine with alcohol, when we react iodine with alcohol, when we react iodine with ethanol or ethanol or methyl ketone in the presence of HCl, then at that point, sorry, it's not in the presence of HCl, but um the presence of HCl, we will actually get yellow precipitates, yellow crystals of iodoform, and those yellow crystals of iodoform indicate that there is presence of an ethanol or methyl ketone. There is a presence of ethanol actually. and this gives this a positive test. But if we are going to react methanol with iodine, then it's not going to the give us the yellow precipitates, which can be used for distinguishing between um, which can be used for distinguishing between uh, methanol and ethanol. So that's all about this video. Hopefully we meet again in another video.